So in this example, we are going to show a one-to-many mapping relationship in using Hibernate. So we have a class called stock, and it is related to a stock daily record. A stock daily record maintains the opening price of a stock, the closing price of a stock, the volume that was traded on that day, and the date of the trade, and the date of the daily record. And the stock daily record also has a reference to the stock ID from the stock class. So one stock has many stock daily records, and every stock daily record has a reference to the stock table. So the one side of the relationship is stock, and the many side of the relationship is the stock daily record. So on the one side, on the stock class, you'll have a set of stock daily records, and on the many side, that's the stock daily record, you have a reference to the stock object. And if you look at the mapping file, what the mapping file in the stock hbm.xml, you have all the other attributes like stock ID, stock code, and stock name in the stock class, but you also have a set of stock daily records which map to the stock daily record table. And you also have a one-to-many XML tag, and you have this one-to-many on the one side of the mapping file. The one side of the relationship is the stock, and its mapping file is stock hbm.xml, and in that we have the one-to-many tag, which is pointing to the many side of the relationship, which is the stock daily record. And if you open the stock daily record hbm.xml, you will see that it contains a record ID, which is an auto-generated column. It also has this key XML tag called many-to-one. So now we are on the many side of the relationship. So the many side of the relationship mapping file will have a many-to-one XML tag, and it points to the stock class, which is the one side of the relationship. And then you have all other properties like the price open, price close, price change, daily volume, the date, and so on. So let's look at the demo file, which is Hibernate-One-to-Many demo.java. And what we are doing in this program is we create a stock object, then we create a stock daily record, and then we set the references on the one side and also on the many side. So the many side of the relationship with the stock daily record, we set its relationship to the stock object, and then on the one side of the relationship we get the set of stock daily records and add the single stock daily record that we just created. So we are setting both sides of the relationship, and then when you save it, you just save the child record, and it will automatically save both the parent and the child. And the way it saves the parent and the child depends on an attribute called inverse, which is defined on the one side of the relationship. And if you see here, the inverse is set to false. So if the inverse is set to false, what happens is the inverse attribute basically determines whose responsibility is it to save or update the child and the relationship. So when the inverse is false, it is a parent's responsibility to save or update the child and its relationship. So the inverse is false, it will first insert the parent, then it will insert the child, and then finally when it inserts the child, the parent reference is still set to null, and then it does an update on the child, and at that time it will update the reference to the parent. And when the inverse is true, that means it is the child's responsibility to save or update itself. So when the inverse is set to true, it will first insert the parent and followed by a single insert in the child. And the single insert in the child will also have a reference to the parent parent ID, which is the stock ID. So let's run this program twice, once with inverse set to false and once with inverse set to true. So before I run this program, let me delete all the data for this in the database. So first, always go and delete the child records and then save the parent record and then delete the records in the parent table. So now I'm going to run this program with the inverse set to false. So now I expect to see two inserts followed by an update. The first insert will be insert in the stock table. The second insert is insert in the stock daily record table. And the third SQL statement is an update which updates the child record with the reference to the parent key. That is, it is updating the foreign key in the child table. So let me run this program. And let's look at the console. And you'll see that first it will do an insert into the parent table, which is the stock table. Then it does an insert into the stock daily record. And if it does an insert into the stock daily record, the stock ID is basically set to null. And then it does an update on the stock daily record. At that time, it updates the reference to the parent table's primary key, which is a foreign key in the stock daily record table. Now let's look at what happens when the inverse is set to true. So let's first delete the data. First delete from the child table. And then let's delete from the parent table. I'm using a tool called DB Visualizer to look at the data in the database. The DB Visualizer is a free tool, is not a free tool, but you can use the trial version for 30 days while you're learning Hibernate. So now I'm going to set the inverse attribute to true and run the program again. And this time I expect to see just two insert statements. One insert into the stock and one insert into the stock daily record. This time the child is responsible for managing itself or for saving or updating itself. So the child will update the stock ID with the parent stock ID in one statement itself, instead of using an insert followed an update when the inverse was set to false. So when the inverse is set to true, it will have only two insert statements. And then you can go and see that the data is populated in the database. Click on the refresh button here and you'll see the new record inserted here, and you'll also see a new record in the child table. So this is how a one-to-many relationship is modeled in Hibernate.